Okay, here's your info for tonight. 1 week from tonight, you will have exam number 5. 2 weeks from tonight, you will have the final exam. Both will follow the same format. We will review the class before, which means tonight we will review for exam 5, and then next week prior to exam 5 you can ask specific questions, and at the end of exam 5 we will review for the final exam, and of course you can ask any questions then, and 2 weeks from tonight before the final exam you will be able to ask any specific questions on the material. So that's the next 2 weeks. Tonight we'll do lecture and lab. At the end, after that, we'll review for exam 5. We'll talk about these topics. RAND, which is a random number generating function. SRAND, which is a seeding of the random number generating function. And time, simply because time is frequently used as a seed value. We'll talk about pound defined, which is a macro definition. And we will talk about exit. I forgot one other thing, command line arguments. Okay, random function. Basically, that is its prototype. It is, you call the function which exists in standard live.h, and you don't give it any parameters because it is a parameterless function and it returns a random integer. Now when we say random integer, there's really, in computer terms, no such thing as a random integer. They're only pseudo-random, which means that, I don't know how to define what pseudo-random means. It means you have a generator that is generating random numbers. Ultimately, that random number generator is not truly random, but it is random enough for our purposes, right? But it is not random enough for cryptographic purposes. You have to do other things besides that, which we will not go into. Okay? So, that's pretty much all there is to rand. It gives you a random number. And it's usually a large random number. It is of type integer, right? So it depends on what you want to do with it. You can do anything you want to do with it for your purposes. Okay. Now, one of the things that is frequently used to assist the randomness is SRAND. RAND stands for random, the S stands for seed. When you give a seed to any kind of algorithm, the seed is a starting place. When you get into database technology, you can define tables that have auto-incrementing columns, usually the primary key. So one of the things you can specify is the seed the first time you create the table, which says, where do you start? That's what seed means. So what is frequently done is you declare a variable of type time underscore t. Time underscore t, some of these things will come to mean more when we talk about town defined in a structure, but more than likely, time underscore t is a structure. Is that true? No, I think it's an integer actually. But whatever it is, it has to be an integer. It's an unsigned integer. But it's just a type. Remember how we can declare structures? We can use type def to make the structure appear without having to use the struct keyword. Time t may be a structure. Probably not. It's probably just defined to be an integer. But it's defined with a meaningful name, okay, for your use. And that happens to be in a function called in a library called time.h, where you can include its prototype. Now, what is frequently done is srand is called using the returned value, which is a time, which happens to be an integer, in seconds since January something in 1970. That's just how it's defined. You can look it up. By calling the time function. Because this is going to give you a pretty variable seed. Because this time is always moving along, increasing by 1 every second. Right? So this helps your randomness. And the point of randomness is to be unpredictable. So whenever this is called, it's at that particular moment in time that the seed is established.
Could you repeat what an unsigned integer is versus a normal integer?
An unsigned integer. An integer has 32 bits on most systems. On some systems it has 64 bits. But it has 32 bits. Okay? A signed integer, which by default integers are signed, uses one of those bits to indicate if it is positive or negative.
Okay.
So if you define an unsigned integer, that means you have all 32 bits to contain the unsigned value. And by definition, it is considered a positive value. That's what unsigned means. We haven't talked about casts, right? This just says, and if you didn't have this cast here, you would just get a warning. We wouldn't get there. But it essentially says, treat this as an unsigned integer, and it makes the call to srand happy. Because srand's prototype is unsigned integer. Right? But if you didn't have it there, you'd get a warning, but it would still do everything it's supposed to do. But time is often used as the seed because it's fairly random as to when the function is called. Okay. And then after that, you just call rand to get your random number out. And if you call rand again, you will get a different random number. That is rand, srand, and time.
What is the range of the random numbers? Could it be like from 1 to like 1 billion? Or
It is from, since this is an integer, it can be from 1 to 2 to the 31st minus 1.
okay.
2 to the 10th is about 1,000, 2 to the 20th is about 1,000,000, 2 to the 30th is about 1 billion. So it's up to about 2 billion,
2 billion.
more or less.
Mm-hmm.
Not, a little bit more
It's a
actually.
little more.
Yeah. That's how it works. Questions? Reasonably straightforward. You also get to review what including libraries means. It includes the prototypes, and the DLLs come along with it. And the RAND and SRAND are in standard lib.h. Time is in time.h. What's the other library we frequently see included? String.h is one of them. What's another one? Somebody? stdio, standard IO. It has fwrite, fopen, fclose, fread, fgets, fs, so on. There are others.
Is unassigned like a reserved word, or is it like a special character that you type on the keyboard?
It is a reserved word.
Okay.
UNSIGNED is a reserved word. Okay. Think about that. It's reasonably straightforward, but I encourage you all in the implicit homework that I did not write up there to write a little program and just see what comes out, or look it up. Okay. Pound define. In its simplest form, it is like that. You say pound define, you say some name, whatever name you want to give it, and then you give it a text string. And then the compiler does simple substitution. Whenever it comes upon some name as a separate token, it will replace it with whatever text string has up to the end of the line. Actually be blank. It'll be blank. It'll leave one blank. Okay. So for example, in standard IO.h, you would actually find that. Remember, we use EOF to mean you can test it, see what the result of an operation is. And EOF happens to be defined to be -1.
So in previous class, you said we can't take something from the user and use that as a variable name, but would that not allow you to do that?
One more time, cannot take.
So like you can't take a string or like a variable, so like you basically can't enter a word from the user and use that as a variable name or something in code, but is that not what define does? If you can put a text string into a variable and then put that text string in the brackets, and then have that replace something that you had already had in code set up for that.
Okay, like for example, what would that code look like?
Oh, so it would just declare a char array, so char 100 equals ARRY, I guess, or A, yeah, and then scanf into the char array. And then if, I guess, above you had that exact line, except instead of some name, it was whatever, or instead of text string, yeah, it was A.
We did that, so define, what name do you want here?
You can still put some name because we haven't written that code yet. Or that code hasn't been written yet, I should say.
And then what do I put here?
Brackets and then A, I guess, unfortunately.
Brackets or just A?
Oh, is that what, yeah, I guess
Well,
A then.
you want brackets or?
I don't know what it's supposed to be because text string is supposed to be in brackets, right?
You can put anything you want here.
Oh, okay. So yeah, then just a semicolon even though the char array is defined after. And then,
Semicolon. Now, the semicolon is not determining the define. Everywhere it appears some name, a semicolon will be substituted for it.
oh, okay.
Okay, go ahead.
And then later it would just be what you're trying to define, the variable that you're trying to replace with what the user inputs. So it could be int some name, as written above. And then wouldn't the define function change some name to A, or A semicolon in this instance?
I think it would replace a semicolon here.
Okay, so it would work. Or it
Would
should.
it work?
Yeah, all right.
Probably. Would it have any, okay, so what does this get you? What have you accomplished by doing that?
I mean, I've honestly tried to do that in every language I've learned, so
Say what?
I don't know, I've just always wanted to be able to do that.
But-
But I think someone else asked that
But what
anyway.
does it accomplish?
Oh, it means that the user can manipulate what your code looks like with intent. So like if you want to call something by something that the user has, I don't know, never mind.
No, it would not take the value that's in A. It would take whatever follows the word some name. It wouldn't take the value.
Oh. Okay.
In other words, this would compile as int a semicolon.
Oh, okay.
And it would say A, it would not have the value of A.
Okay.
But you're thinking, and that's good. So ignore all that, except for the part that thinking is good, because it is, right? Thinking, what if, how could I, these are all good starting places for thought. Questions about, yes, sir?
Does define EOF like only run once when you hit compile at the very beginning?
No, it doesn't run at all.
So
The
does it,
compiler puts it in a table, and wherever the compiler sees EOF, it puts space -1 space.
does it change like written code or does it
Yeah.
only change?
It doesn't change it. I mean,
But
it
does,
compiles it as though it had
okay,
-1 put in its place. It is simple textual substitution during compilation.
okay,
Obviously, it doesn't edit the file it's compiling.
It does or it doesn't?
It does not.
Okay.
That would, you don't want your compiler rewriting your file for you. There have been languages that do that, and that are gone now, because it resulted in nothing but disaster. When people tried to cleverly do things that they had no business cleverly doing because it didn't accomplish anything. Because remember, when you write code for now, but you write code for the guy who's going to work on it 6 months from now who's never seen it before. That's how you really write code. And make it easy on him. Your job is to make his life easy. So define is simple textual substitution. It is not like a method or a function which gets compiled by itself and then can be referenced multiple times in a separate compilation. Too many people try to use pound define as a cheap function, and they should not. It should never be used that way. You find yourself putting code after a define, stop. Write a method. There is some cleverness that you can end up doing, but here's what you need to know. In programming, clever equals bad. Because if you're clever, maybe the guy 6 months from now isn't as clever. Or he's got to figure out your cleverness. Clever is equal to bad. Obvious is equal to good in programming. Okay. There are some other wrinkles to pound define, like parameters that we'll get to, but there are other wrinkles, like how to have multi-line defines. Well, I'll go ahead and tell you. I'll do it in the course of a parameterized one. Because the define, what follows and is replaced, ends at the end of the line. Okay? That's how that's coded in the language. Now, if you do something like this, you can give parameters, pseudo-parameters, to something that you're defining. And then those pseudo-parameters will be replaced. So, if you put a backslash immediately before the new line character, it says include what is on the next line as part of this definition. Okay. I have to think of a decent example. Okay. So we're going to define pseudo-func with the pseudo parameters of x and y to call scanf passing x and y. Okay. This is the best example I could contrive. So later on, could do that. And in doing that, you have created one function for which you can vary the things you're passing. It's a pretty contrived example, because it doesn't look a lot different from scanf with different parameters. But you could end up doing it. Here, let me contrive it a little bit more. You could then add a log statement. So this define ends up being this part, right? Because I put the continuation characters at the end of it. And so to make it, try to make it a little bit less contrived, in addition to doing the scanf, you're always logging what comes back by using some magic function you've created called log. My recommendation, never do that second thing. Write a function, write a method to do it. Okay. But this is very common. I don't even recommend you do that. I recommend you declare constant variables. const int I, and then you can, you know, int EOF is equal to -1. Pound defined came about when memory was expensive and you didn't have much of it. So it effectively said, rather than create these separate functions, rather than take up memory space with a defined variable, we do it in the compiler so it gets jammed into code. Okay? That was why it came about. Everybody now knows pound define is bad. Bad, bad, bad. But that doesn't mean if you find yourself working on legacy C code, you won't see it, which is why I have to tell you about it. Okay?
Is there a reason why we would use type def over pound define?
Yes, they're very different. Type def is defining a type. Def is defined and type is type. So type def is defining a type. And it's an explicit compile type, right? So it's a, for instance, it was most often used on a structure. Type def, struct, whatever, right? But for instance, you're saying the type def int pointer, int ptr, right, just defined as int star, right? I don't know if that's a pound define or if it is a type def. I don't happen to know because, as you have figured out, in most cases they'll work the same. The real reason to not do pound define is because you lose lots of debugging capability. When it starts to debug it, when it debugs your code, it won't give you a reference to something meaningful. It'll just give you a, for instance, if you put EOF, it'll just, when you look at the code, the generated code, you'll see -1. Whereas if you had done a type def of EOF equal to integer equal to -1, your debugging tools would give you a reference to the name EOF, and then you could see its value. So So when you use pound define, you lose a lot of things in debugging.
Why is there a semicolon after standard code?
Because this is treated as one set of code. Right? So you have to separate lines of code by semicolon, right? So the next line of code is going to be log y, but in your use of pseudo-func, you're going to put its terminating semicolon right there.
So is log f before the semicolon too? Or log y, sorry.
Yes, because of these line continuation characters, that says, okay, whatever is here, continue on the next line and don't terminate the pound define. So look it up, read about it, put a little practice in, won't hurt you. In fact, it will help you. Because you just need to know how pound defines work. Any more questions? Think about it, you may have some later. Ten minutes of break, 20 minutes of lab. We'll start again at 7:10. Okay, 2 more topics tonight, and then we'll get to the review for exam 5. Exit. Really good question. Let me make sure it is what I think it is. It is in fact a function. Yes. Okay. So, what is the best way to get him to shut up is to ask him questions. What does return do?
Return the value. Return X.
It will return X, assuming as the value of the program, assuming X is of the right type, as the specified return type of the method. Okay? And I'll be clever, I wrote it in the wrong order. What would happen in that case when I compile that program?
What's the question?
If I took this function
Yeah.
and compiled it
Uh,
and tried to run it, what would happen?
because you return y is float, but this function is
Well, what's going to happen? Is it a compile error or is it a runtime error? Why is it not a compile error? Y is of what type?
float.
What
But
type is expected to be
function
returned?
is- This function is int type.
Right, so this will return a compile error. Okay. Next person, let's change this up a little bit. I change it like that. Y is equal to 3.14. The inaccurate abbreviation for pi.
Return 3.14.
We would return 3.14. Next person.
It's a compiler, it's not expecting to return anything.
How would I fix the compile error?
You can either, well, you can either change the return type for the function or remove the y in the parentheses.
So how would I change the return? Okay, suppose I'm not changing that. How would I fix this?
Just erase y.
That's effectively the same thing. Return semicolon and comment out, that stuff. Right, correct. Okay. Just a quick refresher on return, how it works. Any questions on return and how it works? Pretty straightforward, right? Return exits from wherever it's called. Okay. And return is part of the language. It is a keyword of the language. It is syntax to the language. Now, let me look to make sure. Here. Okay, this is the prototype, as everything in header files are. Well, they're either prototypes or they're pound defines typically. For a function called exit. Okay? You can also use exit. So, let's go this way. Okay, I'm running, let's take the func example I have up there. So I'm running inside a func, and func was called from main, let's say. Had to be called from somewhere, right? When I say return, I have your main. Okay, so I run program main, it calls func, func does whatever it does, and it then says return. So what's going to happen when I run main? What's going to be the net result?
It's gonna print leaving.
It's going to print leaving. Okay. Now suppose instead of return, I put exit. Next person. What do you think is going to happen? No reason you should know this yet. In 5 minutes, you should know it.
Is he gonna stop the program?
That's exactly correct. It'll stop the program. Right then, right there. No further execution is done. Okay? So, when you run this program, what's going to be the output, if any? No output. That's correct. Because exit terminates the program and gives the status of the program to whatever you pass to exit, which in my example is 1. But it's an integer, you pass whatever status you care about. That is what exit does. Sir?
Do we need to know what the status numbers mean though?
No.
Cool.
The reason is because they are user defined.
Oh, okay.
There are conventions, but conventions are just that. They are not even conventions of the nature of a string is terminated by a null. They are conventions of what most people happen to do. Right? Most people happen to return 0 or positive numbers for some flavor of success, and negative numbers for some flavor of failure. You do not need to know that, and it is a convention that is not followed everywhere, and certainly not followed very consistently. Okay. But it does give you a means of communicating this is the point, it gives you a means of communicating something back that is meaningful to whoever ran your program. That's the only reason for the return type of status. And exit is not part of the language, it is in fact part of the library. Okay? And you can call it, and it terminates your program right then, right there. No buffer clearing, I mean, there's all sorts of consequences to it. There are, if you have IOs and file buffers that we haven't talked about, but the way IO typically works is when you do the write, it actually goes into a temporary buffer that you don't know about. Right? And then at some later point, it is written to the disk drive. Okay? If there's anything laying around in a buffer, when you call exit, none of that's completed. It exits right then and right there.
Since that's a prototype, can you define something within the body and display something as it exits, or
No.
no?
Because if you define, because this is a prototype that you included via probably standard live, right? As soon as you wrote your own exit, you're going to get an exit already defined, right? Because it's going to know that it's in a DLL. And it's going to find it in the DLL and say, I can't have two exits. So, in other words, were you trying to be clever and override exit so when somebody calls exit it doesn't? No. Believe it or not, hackers do things like that all the time, but they have to do it in a more complex way. Function pointers is the typical way, which we haven't and will not talk about. But there are ways and ways and ways. To defeat a hacker, what do you have to be yourself? A hacker. You have to have the capabilities of being a hacker. Have you ever heard of black hat and white hat? Right? Where they have white hat conferences? These are conferences of people who go and they tell people how to stop hackers. At one job when I worked for Fiserv, I was essentially the white hat guy for my group. I started off being the group just for my little group, right? And then because I knew about all the hacking stuff before we got there, I ended up being the consultant for all the groups, right? Because you run programs, right? Analysis programs that analyze your code. And the programs say, well, you're doing this, which allows a hacker to do something. You're doing this, which allows a hacker to do something. This is just a bad idea in general. It's probably not. So they have different levels, right? So I had to go explain these to people. Not about, well, first of all, I had to explain why it was an exploitable issue. Because as you know, I always ask why, right? And I always insist, if anyone asking me a question, I always insist that they listen to the why. Whether they take it in or not, it's just like you guys, I don't know. With you guys, I'll find out on the test, right? With these guys, I'll find out when their boss comes and asks me, well, what do you think about blah, blah, blah? And the usual answer is, well, I don't know. He just asked me, I gave him the answer, I didn't know what happened after that. Right? And then if the boss says, well, this is what happened, I'll say, well, whatever. Okay. But that's what hacking is. Right? And you know, you guys may not know this. Google, certainly, I think Amazon, they put out rewards for white hat hackers. White hat is because you're wearing a white hat. In the old cowboy movies, the guy with the white hat was the good guy, the Lone Ranger, and the guy with the black hat was the villain. That's how old westerns were. That's where these terms come from. I never watched a lot of old westerns, but my father lived on them. And his retirement was nearby the house. But the point is that they have substantial rewards depending upon, one, you got to be the first guy to find it, or I think is actually the first 3 or first 5 or however many, right? And the seriousness of what the hacker can do, I mean, Google has paid out $30,000 to an individual who found something that was a big hole, right? That was, I happen to know that because it was advertised in a standard feed I get about probably 2 weeks ago, it was before Thanksgiving, right? But I thought to myself, and then I go look and I look at the exploits. I say, oh, I'm curious now. But I know that guy got 30 grand. Now, how long did it take him to find that? I don't know. Right? These days, the point is to make it harder and harder for hackers to find things. Sorry, tangent. So, don't be a hacker. Be a good hacker. Right? Get your 30 grand from Google. They actually do pay. They cough it up. Because more than likely, you may have saved them a lot more money than that. Exit immediately terminates the program. Flushing of I/O buffers, including output buffers, right? Doesn't happen. Exit immediately terminates the program, does not execute any more things, and it flushes the buffers. Flushes means throws them away. Well, no, flushing a buffer typically means it pushes it on to its destination. This eliminates the buffer. And sometimes you need to do that. Sometimes you run into a catastrophic thing and
I was gonna actually relate to that. Can we set exit to only eliminate a part of the program that we wrote instead of the whole thing, or just the whole thing?
whole thing. What exit actually does is that it eliminates the running process that it is in and any threads that that process has. So we haven't talked about threads in this class. That's for more advanced programming. But you can, in fact, start up another thread from your program, which would be a procedure, right, running independently of your main process. So in other words, let's suppose that you had to do 5 IOs from 5 different network sources. Okay? And my company does this, right? Because we get data feeds from all sorts of places. We show you the list of apartments. There's a lot of data there. You know, minimum rent, maximum rent, all sorts of things about the neighborhood, this and that and the other. Okay? So we'll fire off 5 threads. Go get this piece of information, go get this piece from various places. Okay? And then we bring all that data together into the finished web page for your search, and we show you whatever you're searching for. This is more and more common in the industry. Okay? That exit will also immediately kill any and all threads that you have running. So I'm glad you asked that, because we haven't talked about threads, but should you have threads running, that's what will happen. In fact, when you do an I/O to a disk file, a separate thread is running, flushing that buffer behind the scenes that you don't see, only the I/O system knows about it. Right? But all of that gets killed as soon as you call exit. And that's why it gets killed, so that it minimizes any side effects. So in other words, suppose somebody was busily encrypting your hard disk, like for ransomware, via your program, because they were able to inject some code. You figured out exit, it stops everything in its tracks. So hopefully not all of your disk is encrypted. Okay, questions about exit? Now, while we are on the subject of main, the last topic for this evening, and in theory for the class except for the review, is command line arguments. Okay? So normally, for our purposes, we've been writing C programs with nothing in here, right? No command line arguments, because that wasn't relevant to what we were doing. So let's suppose you want to have some command line arguments. They call the first argument has to be an integer, and it has to be named argc. Excuse me, it doesn't have to be named argc. They typically call it argc. It's argument count of arguments. And the next parameter let me see how they write it so that if you look it up, it looks the same. Two ways to write it. A character pointer to an argument named argv array. So what that essentially gets you is an array of character arrays. Okay? That is the other way it is sometimes written. Because remember, character pointer and a character array, essentially the same thing. Or an array pointer and the array itself are essentially the same thing. This is a pointer to a pointer of arrays. So, in fact, and this is all done by the operating system when you run your program, which I'll show you in a second. Right? So this is an array of arguments. So let's suppose on your command line, and your program was compiled as myprogram.exe. This is on a Windows system. Apple systems and Unix systems aren't terribly different, except they're less suffix oriented. But if you said my program, and then you said ABC on the command line, what would actually get passed to your program, assuming you had those parameters to access, argc would equal 2. And I'll tell you why in a moment. This is the y. The very first argument is the name of your program. That's just what the C standard says. When you do this, the first argument is the name of your program. And then the second argument is going to equal whatever the argument was. Now you can see why this is useful. It allows you to pass something to your program and tell your program to do whatever, or to be meaningful, or to what file to open, or whatever you want it to be. Right? It's an argument. So therefore, it's up to the programmer what the argument means. So, where did we leave off? Did you ask a question?
I asked the question.
So The lucky guy. Can argc ever have a value of 1?
I don't know.
50-50 chance.
No.
In theory, the answer is no. But there's a case that I'm going to have to check out. Because suppose you ran it, you had these parameters, and you didn't pass any value. I believe it is defined that this will be 0, and there will be nothing here, actually. You know what? I think I did look that up already. Hold on. I tried to look it up and it did not have a definitive answer. The reason it may not have had a definitive answer is because the semantics of the command line in Windows, I think they call it command line in Unix. I don't know what Apple calls it, right? The semantics of this are operating system dependent. Usually, a space starts another argument. Unless we put quotes around it. But don't worry about that stuff. This is not important. Right? Worry about this stuff. This is what's important. What is passed to the program, the count of arguments, and the arguments themselves. Always remembering that the first argument is the name of the program. That is command line arguments.
I still don't get what are those comment lines right there?
These right here?
No, on the formula. Yeah, next to argument, yeah, those. Are
Yeah,
those
I just
comments?
put // because unless I'm writing real code, I always put // This is just telling you the value of argc, for this case, is going to be 2. And what the value of each of those character arrays, which will contain strings, null terminated strings, will be.
Wait, so does it start at 0 or 1? So would 1 be a count of 2 then? For the int argc at the beginning?
They all start at 0.
Okay.
In C, all arrays start at 0. So that's a way of saying if all arrays start at 0, and the very first thing is the name of your program, it goes into 0th entry of that array of arrays. And the actual parameter that was specified changed it. Goes in 1. And so on. You can specify multiple parameters here. And then your program reads those parameters and does whatever it is coded to do with those parameters. Somebody had their hand up?
I was gonna say, could you give an example of like when or like how this would be used, but it kind of came along with what you just said.
Okay. Since I'm gonna give you a real example, let's make sure we have the name of the real example correct. Yep. If you enter that into a Windows command line, it runs a program. The program's name is copy. Copy.exe is what its actual file name is. And it will run, and it will read the parameters you give it, just like this. And it will copy file 1 as file 2. Or whatever names you put in here. And you can give it wildcards and all sorts of things, and it'll do all sorts of things. But that is an example. And there are a lot of programs like that. Okay? If you happen to be using an IDE like Visual Studio, like Visual Studio Code, whatever, when you go to build your program, it runs a program called MS Build. And it passes parameters to it exactly like this, except the parameters are the directory you're in and the name of the project file and so forth.
So then, when you're, for example, if you were the person writing the program copy, it would be int main, and then the amount of arguments, which would be 3, and then you'd give the first one, which is the name, which is copy, and then the second one, which is file 1, and the third one, which is file 2.
Yes. The name might be copy, it might be copy.exe.
Right.
That's going to be operating system dependent. I actually think it's going to be copy.exe.
And then the body would just be whatever gets file 2 to copy to file 1.
Yeah. So your program might do an fopen on one file pointer with mode R, an fopen on another file pointer with mode W, and then read, write, read, write, read, write. In fact, I think it does something more efficient operating system-wise than that, but that would work. It doesn't, that mechanism would not preserve timestamps on the file, whereas in actuality, that program does return because it uses kernel operations. But it still has to do the same thing. It still has to do exactly what you would do. It has to read those parameters to determine what to do and what to do it to. There's lots and lots and lots of programs like that. On a Windows system, if you go look in Windows /system32, I think, you will see a ton of programs that end in .exe that do exactly that. You see copy, you'll see xcopy, you'll do slightly different things. So in fact, writing these trivial programs, you will discover that sometimes you might want to write a lot of them when you're automating a pipeline. In other words, and people have already done this for you, but you have to buy their tool. You have to buy Microsoft Team Foundation server, right? You have to buy the names escape me. There's a bunch of them out there. There's 4 or 5 that are very prominent. Or you might want to simply write your own program to build your programs automatically. Once a night, everybody checks in their code. At midnight, your program starts and it runs all the build programs. And it sends the output somewhere so that when everybody comes in the morning, all the work that day was built to your development server. And they can test their stuff to make sure it works. Lots of reasons to do it. Questions? The main point is to make you aware how they work functionally. We have these two parameters, an integer, which is the count of argument, an array of arrays, which you'll have one array for each argument, for each in the count. And we won't go into the details of what you might be doing. The point is telling you how to get arguments into your program. What you do with the arguments is entirely up to the program and what they mean. In the case of copy, one is source and one is destination. Questions?
What about the location? So like when you open the terminal, I think on any system, does it not matter where copy.exe, for example, is if it was in Windows?
It does.
So,
That's going to be operating system dependent.
okay,
But I'll give you the example. Suppose copy existed in, it's a complicated answer.
okay,
I'll say it that way. But you have to, the operating system has to be set up to look wherever copy exists to find it and run it. If it doesn't find it, it will not run it. It'll give you an error saying such and such can't be found.
okay,
There are environment variables which say, by default, look at these directories. And you can adjust those environment variables, which will make it look automatically. But in general, for development purposes, if you're writing your own programs, it's going to be in my project directory, slash my project 1. You're going to have to adjust where this is pointing to read it. Or you're going to have to give a fully qualified name of the program. Either one of those two things work. And that's the case on almost all operating systems. In fact, it's the case on every operating system I know.
Instead of doing int main, can you also do void main and it's work the same way?
Yep. In your program, when you say return 13, in your main program you say return 13, if you have void here, it'll give you an error. But if you have an int there, it'll give 13 back to whoever called the program, which might matter, right? So for instance, if you're running MS build, it'll say build succeeded or build failed, or failed with errors, or failed with warnings. And then you can, after running the program, you can get that result and say, okay, should I run the next program? No, it failed with errors. I certainly don't want to try to copy the results, because in theory there are no results. Right? So that's why. Questions? Most people don't use, except programmers, don't use command line arguments. They use GUIs, graphical user interfaces, GUI. Right? On your phone, you move your finger around. On your laptop, your desktop, you have a mouse pointer, you have a keyboard. Right? So most people don't use command line things unless you're a programmer. And even programmers don't use them much anymore, unless you're doing like automating a pipeline, things like that. Questions? All right, 10 minutes of break, 20 minutes of lab. We'll start again at 8:25.
could you repeat that?
8:25.
Thank you.
Okay. Any questions about any of that? further review. Everything through exam 4 you're responsible for. But exam 5 covers all the stuff we're about to go over. But preceding stuff you need as a foundation for some of the questions, number 1. And number 2, sometimes questions are repeated from before. Okay? All right. And some of the stuff we've already reviewed tonight. Okay. F open, F scan F, F print F, F get S, F put S. Any questions? They all, of course, have their parameter list. And return values. You have to know what all those are. Any questions about that set? And you can ask specific questions at the beginning of class next week, right before the exam. F write, F read, F seek, and modes used with F open. So R, R plus, W, A, so on. Questions about that? So,
It seems like fprintf can do everything that fputc or fputs can do. So why use fputc or fputs?
I'm thinking. I think you are largely correct. But let me make a note. I will come back with a specific answer at the beginning of class next week. Yes, I'll find out and let you know. And the answer may be, you can do the same thing. Just like with printf, you can do the same thing with printf. You can do the same thing with fprintf using standard out as the parameter as you can do with printf. So the answer may be they are the same. So I'll find out. Okay. Questions?
How can you write what you just said, like writing fprintf, making it so that it's equivalent to printf?
That'll print out D, 3, right? Assuming I got standard out in the right parameter order, that'll do exactly the same thing.
So the standard out is like basically just command line, right?
By default, yes. You can change it. You can change standard out to write to disk file, for instance, if you want to. You could say fclose standard out, and then you can say fopen standard out, because you have the pointer to it, right? You can do another function that opens it and points it somewhere else. But by default, standard out is pointed to the monitor, standard in is pointed to the keyboard.
So then for fscanf, you could just write standard in into the beginning.
Yes. You could do the same thing as scanf, yes. Assuming that's the right order of parameters.
I think that's correct.
I think it is too. I think it's, so these guys that have the file at the end, the file pointer at the end. Okay, questions? Any questions about modes with fopen? They're reasonably straightforward. Any questions about fwrite and fread and doing binary output or input versus ASCII output or input? In other words, fscanf, scanf, fprintf, printf, fgetS, fputS are all doing things with essentially ASCII. Okay? ASCII characters. Whereas fwrite and fread, you're simply passing it a pointer to a set of characters. You're passing a pointer to a type. The type may be a character array, it could be a structure, it could be anything. But with fwrite and fread, you're doing binary operations bit for bit. There's no interpretation. Okay, any questions?
So you said fgetS passes gets past fgetS gets past type,
Fast. What?
a type, like a structure.
No, I thought about fwrite and fread. They get past a pointer to something that you're going to write out or read into. fgetS and fputS, the S is for string, right? And they operate on a string. They'll read in a string until a null is reached or the end of the line is reached. Okay. No more questions? That's it for tonight. Next week, you can only ask specific questions, not show me an example of. I'll be here for whoever has questions. If anybody needs to pick up your exam 4. I have them here. Have a nice evening. See you next week.